Hey, Abigail. Maria, Luke. It's great to see you guys
Hi.
today. Having a good day so far? Good. Wonderful.
I have a question.
Yes.
For the first lab report, is the submit where I'm going to submit it in the modules this week, or are they somewhere else?
Hold on just a second. Let me drag this. Share my screen. Okay. So right here, this is your assignments. I'll talk about that in a second. All right. So this is this week right here. So the required lab number 1, effects of hydrogen peroxide on germination. If you scroll down a little bit, you'll see right here where it says part 2. This takes you to, that's the lab you're talking about, right? Yes. So this takes you to this lesson right here. You will answer these questions one at a time. So you're going to tell which of your seeds germinated first, some observations, and then let me go back to this. And let's see here. Submit. Let's take a look at this. Okay, so this is not an actual lab report. You're not writing out a lab report this time. You only have to do 1 lab report each semester. I'll let you know when it is. For this one, you answer some quiz questions about this lab, and those are the ones I just showed you. Let's go back there and I'll show you again where it says part 2. Right here. So those are the questions that you're going to answer. Okay. Now, if by the time this due date comes up, you haven't finished your lab, that's fine. Remember that all the quizzes and tests in my class, my due dates are flexible. So it's okay if you're a little bit late, but you're going to answer these questions. Which of your seeds germinated first? As you watched over several days, what did you notice? Give a little bit of detail after germination. What can you conclude based on your observations? That's all you're going to do for this lab. So there is not a formal lab report. There will be one coming, but there isn't one yet. Okay. Any other questions? Thank you for asking. I would always rather you guys asked if you have any questions. Okay. So we are, there we go. Got the screen share there. So I have a couple bits of information, of course, for the first 2 lessons. We have to cover all the business end of things. So first of all, please remember, when you write to me to ask a question in Canvas inbox, give me a lot of details. Give me the name of the lesson you're asking about, the question number, the specific details of your question so that I can help you more quickly. The more detail you can give me, the quicker I can help you. All right. I also want to talk about this plagiarism check. So you're going to be turning in some things soon that are more written assignments. And I want you to understand about this, that we are all learning together. So you're going to get a report when you submit something. I'm actually going to show you what a report looks like in a different class. So let me turn this one on. So let's take a look here. So this is just a fake student account that I have. And you can see here, if you go to grades, you'll be able to see down here, this little arrow right there, that's the written report. If you click on that, it takes you to the actual report, and it'll tell you what % of your work that you submitted came from another website. So you can see here, only 7% of this was from another website, 3% from AIM Academy, 2% from Wikipedia, 2% from Socratic.org, 1% from, you get the idea here. So I'm not concerned about a 7%. You know, that's insignificant. I'm not even going to be concerned about anything that's lower than a 30% match. If it's more than that, I'll contact you to discuss it. We are not using plagiarismcheck.org as a way to catch you and trap you and, make things harder for you. We want to use it as a way for you to learn. So if you are here, you're looking at your grades, or you're looking at the lesson itself, right here at the top of the lesson itself, you can see this number. If you see that and it's 45%, 50%, and you know that you didn't plagiarize, you know you didn't copy and paste from anywhere, still don't worry. I'm going to contact you. We'll talk about it. You'll reassure me and I'll believe you. Simple as that. If it is something that like some of these questions, like this one, name and give an example of each of the 4 groups of organic compounds found in living things. There's only so many ways that you can answer that. So it's going to be somewhere else on the internet, probably in exactly the same way that you worded it. So if you get one that's 65% right there, and it's kind of blue or red, and you know that you did some copying and pasting, that's when you want to go, okay, now I know what's not okay for me to do. And then you go back in and you rewrite it and you resubmit it. That's why you get 2 submissions. Okay. Anybody have any questions about plagiarism check? We are all learning. This is an experiment for the whole school, learning how to use this program. So we will reevaluate as we go. All right. Another bit of important information. Can you guys all see that where it says supplies needed? Okay. So please be sure that you look ahead at the supplies for upcoming weeks, because some of these supplies are things that you need to buy. I try to use supplies that you have at home, but sometimes you're going to need to place an order or go to a store to buy something. So for example, in a couple of weeks, we're going to be doing a lab together in our live class, and you'll need some things that you probably don't have laying around in your home. So here are the things that you're going to need for that lab: safety goggles, bromothymol blue, small jars or test tubes, a drinking straw, a water plant, and water. You probably don't have this chemical called bromothymol blue laying around in your home, so you're going to have to buy it. Now, if you go to the supplies list, there will be some instructions on different places that you can buy it. So once again, I'll drag this in, and if you go to the assignments page and you look here, assignments needed for the chemistry of life, assignments needed for biosphere, for a required lab. This one right here says, where is it going to be? Photosynthesis. Supplies needed for photosynthesis and our live class the week of October 15th. So you click on that, and right here it tells you the places you can buy bromothymol blue. All of these. You might also be able to go to a science supply store, but those are some links that worked. As of a couple weeks ago, they were all accurate. Maybe they're not. If they're not, let me know. But you just don't want to wait until the very last minute to order your things. Now, if you can't get all the supplies, that's okay. You can always observe when we do a lab in our live class together, but this is a pretty cool one. I think it's worth doing. So please try to get the materials and do the lab yourself if you possibly can. Like I said, though, don't wait till the last minute to look to see what the supplies are, not just for this lab, but for all the ones that are coming up. Okay, the next thing I want to talk about is not using the grades tab to find your assignments. So once again, let me look in here and I'll show you what I mean. So that's not the right one. Okay, so if you look over here on your right side, left side of your page, you'll see where it says grades. Now, a few students have told me that they're using this in order to navigate to see what's due. This will contain some things that are not due, and it will not contain some things that are. I do not recommend using grades or the calendar. The calendar is the same way. Right here is the course calendar. You can use that as a general rule, but don't use it to see what's due and what's not due. There may be some that are due that are not listed on this calendar. Also, when you're on your home page, go back to it. Here we go. When you're on your home page, you'll see some things over here that say to do. Don't use those either. What I recommend you do is either click where it says assignments or click where it says modules. They both take you to the same place. If you click on assignments and work your way down the list, right here, It'll tell you if you finished them or not. You know, when it says click that you did it or that you submitted it, it'll tell you if it's done. Work your way down this list. That way, you know, you're not doing anything extra and you're not skipping anything that's important. Another important thing that I wanted to show you that is new, we just started getting these from Canvas. See here on the homepage where it says click for class recordings. So this is where I put the recordings of our live classes. So if you have to miss a class and you want to watch the recording, this is where you go to get it. You guys are in the Tuesday section, so this is where yours are going to be. So this is the one from our first class. This was last week. And right underneath here, you can see where it says meeting summary. Click here. If you click there, it will take you to an AI generated summary of our live class. It'll give you a quick recap, some of the steps, and then a summary of each of the like headings, the kind of things that we covered. Now notice at the bottom, AI generated content may be inaccurate or misleading. That's true. If you read something in here that doesn't seem right to you, it might not be right. It's just kind of maybe a useful way to you. If you remember that we talked about something, but you can't remember what we said, you can quickly go there and look for it in the summary. All right. We are going to use discussion boards a lot. Many of the discussion boards require pictures. Please make sure that you are uploading a picture and not a link. So what you want to do is you want to check that to see if it actually put in a link. So when you put in a picture, leave that lesson and then come back and look at it and see if it's just that blue link there, you're not going to be getting credit because part of the assignment is uploading the picture. Make sure that your image is showing. All right. Okay, so I have a poll question for you guys that I want to ask. Here you go. All right, answer the poll. Do you like jokes or riddles at the beginning of class? Some students do, some students don't. I've had some positive feedback and some negative feedback, and I want to see what your thoughts are. A couple more answers. Oh, this is hard. Look at guys, look at the answers we got here. 2 of each. All right, so I'm going to say we're still going to do jokes. Those of you who say you'd rather just skip it and get to the right to the class content, you're going to have to deal because 4 people, either half the, two-thirds of the class either likes them or is not opposed to them. So I'll try to keep the jokes to a minimum, but it adds a little icebreaker to the beginning. All right, so here's a joke for you. There's a species of antelope capable of jumping higher than the average house. Did you know that? This is due to its powerful hind legs and the fact that the average house cannot jump. I like that one. All right, what about this one? What do you call a pod of musical whales? Any of you guys musicians? A pod of musical whales is called an orchestra. An orchestra. All right, that's going to be it for today. All right, let's do a couple more of those get acquainted questions. I think this is a good way for us to get to know each other a little bit at the beginning. So using 1 or 2 words, type in your answer to these questions. First, what crazy activity do you dream of trying someday? You define crazy. Would you like to? None. Bethany doesn't want to try anything crazy. You want to just live a stable life, right? No risks. Deep water diving. Yeah, you got to be careful with that deep water diving. Come up slowly. Anybody else? Traveling to remote places. Skydiving. Yeah, Christopher, Charlotte, those would be mine too. I want to skydive someday. I have a brother who did it. He said it was awesome. Bungee jumping. It's okay. I don't know. Is it B-U-N-G-I-E? I'm not sure how you spell bungee either. There you go. You're right, Bethany. B-U-N-G-E-E. That's it. All right, here's your next question. What 2 things do you consider yourself to be very good at? What are you very good at? Basketball and math? Math is a good thing to be good at, Chris. It'll serve you well. Probably basketball too. Literature and playing piano. Awesome. Sewing and spray painting. What do you spray paint, Abigail? Painting and swimming? Like that. Horseback riding and cooking. Canvases mostly. Very cool. All right. Now, the obvious follow-up question to that is, what two things do you consider yourself to be very bad at? Bethany's good at self-reflection and animal welfare. What are you not very good at? Math and sports. Opposite of Chris. Spelling and baking. Maria, don't judge yourself on bungee. That's a hard word. maybe other words are easier. Anything athletic and math. Math and drawing. Ooh, math's coming up a lot there. Chris, you may have to give a tutorial on math here at some point. If there's any, fortunately, with biology, there's very little math. When you get into physics, chemistry, then there's more math. Not so much right now. All right. What is the weirdest food you've ever eaten? Haggis. Crickets. Yeah. Chocolate covered or just plain? Live squid. Plain. Oh, cow heart. You've eaten cow heart. Wow. I dissect them. We will dissect one later in the year. Freshwater eel. Awesome. All right. Here's another one. What type of music do you listen to? All of it. I love that. Oh, the open mind involved in listening to all of it. A little bit of everything. Excellent. Classical and Christian. Classical music's great to listen to while you are studying. There's actually been a lot of studies that show that when you listen to classical wordless music, like just instrumental, it actually can help you to remember. Mostly musicals and Disney. All right, how about this one here? What is your most treasured material possession? This will be our last question. So this is not a living thing, not a person or a pet. Your most treasured material possession. Maybe the thing you would grab if you had to run out of your house quickly. Luke's not sentimental, all right? It could be practical. It could be something highly practical. That's kind of a hard one. See, if I allowed you to put living things in there, you'd all have a quick answer to that. But when you take living things out of it, what would you got? A photo album maybe, or a laptop? Passport. Ah, passport. Yeah, with passport, you can go anywhere. Your pocket knife. Cool. Cool. All right, let's jump right into talking about that Jello enzyme lab. So this was an optional lab. You guys didn't have to do it. Did anyone bring their lab sheet with them to class today? Bethany, you did? Okay. So Bethany, did you get what you want to talk about your results? Tell us briefly what you discovered, or you can hold up your lab sheet if you want to. You're muted. Well, you're not muted, but it's not working. Well, see if you can get it to work. So hopefully if you weren't able to do the experiment, you were able to watch the video that I had of it. I do try to post videos when I can so that you can watch them if you can't do the activities. For this one, I put together a little synopsis of the lab. Now, I didn't make this one. I might do this. That's fine. Doing it after class is fine. This is not me. I didn't do one of myself. I found this online. But this demonstration also shows you the importance of staying current with the lessons. If you keep up with the lessons and follow the due dates, it will make what we're doing in these live classes a little more meaningful for you. So let's watch this short synopsis. There's no audio with this. So there's the instructions. This is how the lab was set up. So all of the Jellos were put across with the labels on them. Canned, that was the control. Fresh, frozen, and canned pineapple. After 5 minutes, what happened? So you can see after 5 minutes, the fresh is sliding around a little bit. The frozen is still firm. The canned is still firm. After 30 minutes, continuing to observe every 5, we can see that the control is still firm. The fresh is sliding around. The frozen is next. And it's pretty firm, and so is the canned. All right, so Bethany, the canned sunk the most, then the fresh. That's interesting that the canned sunk the most. So that's a little outside what we would expect. So we'll talk about that in a second. So this is the chart that I gave you guys to do for your data. I will often give you a chart or something like this to complete when you're doing a lab, especially when it comes to doing a lab that we will be doing a lab report for. Because once we get there and you have a lab report to do, I'm going to walk you through the process of writing a lab report. I'll teach you how to do it in one of these classes before you actually do it and submit it. And there will be a section just for data. This would be the data. This would be what you would turn in for your data if you were doing that. Now, this is what my results were. So my control was just the gelatin, stayed firm the whole time. So did my canned. It stayed firm the whole time. I had the most obvious effects in the one that was fresh pineapple. Now, Bethany got different results. Her canned was the most, and it sank down in, and then her fresh sank down in next to that. Now, we could troubleshoot this. So when you're having a discussion about a lab, whether it's in person or in a lab report, you would talk about what might have happened. Why might the canned have worked? Because bromelain is a chemical that's found in pineapples. And that bromelain has 2 enzymes in them. They're called proteases. So enzymes always end with the letters ASC. That's how you know it's an enzyme, and almost always. And protease is an enzyme that breaks down protein. In this case, it breaks down the protein called collagen, which is a very common protein in living things, in humans as well as pineapples. Now, in a pineapple, up to half of the protein content of a pineapple is bromelain. So plants have these proteases to break down protein in response to things that are happening in the environment. They might need it for germination. They might need it for fruit ripening. They might need it to ward off predators. There's different reasons that they're going to have those. People have some of these proteases that break down protein for digestion, to help us to digest our protein in our foods. So I want to see what happens after 24 hours. Now, you weren't required to wait 24 hours for your lab, but this is an example of how we can often take experiments a little bit farther. So we can experience what would happen if we left it for 24 hours. So let's watch this one.
There's no change. Fresh one, as you can see, the pineapple has some. It's actually activated in the gelatin. The frozen one has some movement, and there's some digestion of the protein in gelatin by the enzymes bromelain. But it can have pineapple. There's still no movement. It doesn't glide over the gelatin. And it's still the same.
Now, what happens is when you put fresh pineapple into Jell-O, that bromelain, the enzymes in the bromelain, break down the protein into smaller pieces. Now those smaller pieces can't trap the water and the other molecules in order to give it its form. So the water separates out and it gets kind of watery. The protein basically breaks down and the water is released. Now, usually canned pineapple doesn't do this. The heat from the canning process inactivates the bromelain. Usually that's what we see. Now, in Bethany's case, that's not what we saw. So probably what we would do is we would run that experiment again to be able to see whether we have the same effect or not. When an experiment doesn't turn out the way you think, you generally are going to run it again and see if there was an error somewhere. So we're not completely sure. But no matter how an experiment turns out, we often learn as much from experiments that don't work as we do ones that do. And you can always write a good lab report if you have done an experiment, whether it turned out the way you thought it was going to or not. All right, we are going to use the rest of the time that we have now to do this interactive lab about enzymes. So enzymes are really, really important in living things. Without them, we would not be able to function at all. You guys read about them last week, if you're staying with the due dates, but we can use this lab activity to learn more about them. Now, you will need an email address in order to sign in. And when you sign in, be sure that you use your real name, because I will assign some of these in the future as lessons. And in order to get credit, I have to know who you are. So don't use a nickname, use your actual name. Bethany, I didn't use Dole. I used another kind that I wasn't familiar. Maybe that's possible. You know, you can try it again if you'd like to for your own learning, but it's not required. All right, so here's what we do to go to learn about to do this interactives. So you are going to go to www.pivotinteractives.com. I'm going to type it in. And you can copy that and paste it into a new window. Go to pivotinteractives.com. You're going to put in the class key. So let me show you what this is going to look like. So when you go to Pivot Interactives, it'll look like this, pivotinteractives.com, and you'll see right up here where it says students join a class. That's what you're going to click on, that red square, red rectangle that says join a class. Once you click that, it'll open up a space for a class key. Now the class key is going to be, I will type that in for you, it's going to be 4F, wait, I'm not going to tell it to you yet. 5801. Okay, there I typed it. It is 4 lowercase f, 8 lowercase c, 5801. You should be able to just copy and paste that right into that class key. You only have to do this one time. From now on, you'll be in. All right, then once you put the class key in, you'll see here, AIM Academy Biology, Joseph is the instructor, click confirm. Now, since you don't have an existing account, you're going to create a new one. You're going to click right here where it says create a new Pivot Interactive account. You're going to create the account with your email and password. So right here, that's where you're going to put in the email address that your parent wants you to use. You will confirm that email address, put in your real first name, your real last name, and then choose a password. Choose something that you will remember. I'm not going to do that because I don't want to create another account. All right. All right, from now on, you'll just be able to log in using your username and password. And I'm going to go to the classes. You should see, when you do that, you should see one that says, oh, wait. You should see one that says copy of Intro to Enzymes. But I'm not sure why it's giving me. Okay, here we go. When you click on that, it should open up a window that looks like this. So you should see this activities, your learning objectives, and part 1 human digestion. Is anyone not there? You're all there, you can all see that. Okay, so we're going to go through this one together today. We're going to go through the lab so I can show you how this Pivot Interactive works. They all have about the same kind of format. Now, this one has a ton of questions. It has like 45 questions. We'll get as far as we can today, and then you can finish it up on your own. This is not graded today. In the future, when I assign something and it's graded, it will not have 45 questions. I will take out a bunch of the questions, but this one I wanted you to see how it comes so that we can look at different question types. All right, so the first thing that we're going to do is read this content here about part 1 human digestion. If you want it to be read to you, you can click on the little microphone there, but it reads in that dumb computer voice that I think is really hard to listen to. So only use it if you need to. Starch is a complex carbohydrate that plants create to store energy. It is a common part of human diets and found in foods like potatoes, corn, rice, and grains. In the video below, we see starch right here mixed with water in a test tube. Then the chemical IKI and more water is added. So IKI stands for iodine potassium iodide, and it is a chemical that is used to detect the presence of starch. We call it a reagent, and it'll tell us if there's starch present. So clearly there's starch present because we have this starch with water in the test tube. So we're going to then go over, once we've read the background information, we go over here to number 1. Observe the negative control in the video right here, trial negative control. We're observing that. A 1% starch solution is added, and then the IKI indicator. Finally, a small amount of water is added. We're going to identify the color of the starch solution before the IKI is added. So let's start the interactive and watch. This is now, water was added. Now, what color is that? So we can hit the pause button. What color is the starch solution before the IKI was added? Cloudy white, dark blue black, clear colorless, or yellow. You would click the correct answer, which is cloudy white, and then you would submit your answer, and it tells you correct. You got it right. If you clicked yellow or dark blue, it would say try again. You get a couple of options. In this one, it gives you 5 possible answers. You can, I don't know why you need 5 because there's only 4 choices, but they give you 5. Now, continue observing the negative control video in the interactive. Now we're going to identify the color of the starch solution when we add that IKI, in the presence of IKI. So let's watch until the IKI is placed in there. Okay, this is stirring the starch solution. We just put the IKI in. Okay, let me back up just a little bit, and there, that's the IKI. What color is the starch solution in the presence of IKI? You choose the correct answer. It turns blue or black when the IKI is added, and click submit. Correct. Now we scroll down again. The third thing we're going to do, continue observing. Now we're going to identify the color of the starch solution after more water is added. So water's going in right now. You can see it being splashed in there. So what color is it after that water has been added? The options are the starch solution is clear, it's cloudy white, it's yellow, or it remains dark blue. I'm going to click a wrong one. I'm going to click the one that says is clear, so you can see that it says try again. Observe the video, watch for when more water is added. Then I'm going to try this again. I'm going to say it remains dark blue. That is correct. So I got it right on my second submission. Okay, you guys all doing this? You all working along with me? Good. Now, make a claim about the starch in the test tube after the water was added. Hint. Notice there are hints on most of these. If you click I need a hint, it'll tell you something that might be helpful. This one, it's right there.
Hint: remember the IKI detects the presence of starch with the dark color. What color are the contents before and after the water was added?
Okay, so that's the voice. And I like that it calls it IKI. It's IKI, but it calls it IKI. So make a claim about the starch after the water was added. Can we say that the amount of starch stayed the same, the amount of starch decreased, or the amount of starch increased? What do you guys think? What claim would we make based on that?
Decreased?
If the amount of starch decreased, we wouldn't see as much of the blue color. The blue color would go away. It stayed. Let's look at it again. Whoop, cancel. Let's look at it again. So there's the starch, there's the IKI and the water. Since the color stayed the same, we can assume that the amount of starch stayed the same as well. Because the color didn't change, the color stayed the same. All right. Now, we're going to next, number 5, click the change button and select human saliva. Right here's the change button. We're going to put human saliva and load. Now we're going to click the play button and observe what happens after the saliva is added. So I'm going to let this play until the saliva goes in. So now we've got water being put in there. It's being stirred. That's our starch solution. Now the IKI has been added, turns to dark blue because there is starch. Now we're adding the human saliva. Watch what's happening. Why did it stop? Okay, watch what's happening now after this. It froze for a minute there. Over time. Oh, why does this keep freezing? If it freezes, just click the pause and play it again. What do you observe happening after that saliva was added? Doesn't usually freeze like that. Might be because we're in class. But you can see what's happening. So now you choose in here, describe your observations. The color changes from clear to dark. Color changes from yellow to clear. The color does not change, it remains dark, or the color changes from dark to clear. So it started dark when the IKI was added. Once we added that saliva, after the addition of saliva, now it's clear. So now make a claim about the starch in the test tube after the human saliva was added. Now, since it's not blue anymore, and the IKI is blue in the presence of starch, now we can assume that the starch in the test tube decreased. We don't have as much in there. We don't really have any in there because it's clear again. So that is correct. So now what do we know about the saliva? Make 2 claims about the saliva. Okay. All right. Saliva is no different than water. Saliva has differences from water. Well, when we put water in, nothing happened. When we put saliva in, it changed color. So we know that saliva is different from water. Something in the saliva increases the amount of starch in the test tube. Did the starch increase? No, it didn't increase because it didn't stay blue or turn darker blue. Something in the saliva decreased the amount of starch. That's what we know. It decreased the amount of starch. Something in the water increased the amount of starch or decreased the amount of starch. No, neither of those are true because when the water was splashed in, there was no change. Nothing happened. So we know that neither of those is true. Submit our answer. That is correct. Now, we write there's a text box here. Speculate about the relationship between molecules in our body and the relationship with the food we consume. So you would, if this was assigned, you would type in what you think about the relationship between the molecules in our body and the food that we eat. All right, now we would move on to part 2. You're gonna need to click to make part 2 go to open up, but you have to lock and continue first. So hit the lock and continue. Again, for this one, we're not being graded, so you don't have to complete that last box. All right, now we're going to talk about the function of enzymes. What do they do? In the last section, we determined that our body must have molecules that make things happen differently. We call these molecules enzymes. Let's explore a couple of different enzymes and see if we can see a pattern that describes their function. Right, that's the background information. Now we go over to number 1 and see what we're supposed to do. So the first enzyme we will be investigating is called amylase. This enzyme breaks down carbohydrates within the digestive tract. In the video, there are 10 test tubes. Each of these test tubes has a starch solution in them. The solution contains 0.1 grams of starch dissolved in 5 milliliters of water and the option to add the amylase enzyme. So right here, there's no enzyme added. We can change it to say yes, enzyme added. We're going to leave it no for now. A sample from the reaction tube, that's right here, is going to be dispersed into these indicator tubes at, it says 20, but it's actually 10-second intervals. The indicator turns black in the presence of carbohydrate. A black color means carbohydrates are present. The gold color means there are no carbohydrates present. There's nothing to do in this one. This is just information. Now we scroll down here, there's something to do. A 1% starch solution is in the test tube. IKI indicator is added. Now we're going to observe the interactive with the following conditions selected. Starch, yes. Enzyme added, no. Now we're going to watch and we're going to describe the observation from the video. So watch what happens. There's no enzyme in any of these test tubes. There's just the starch, water, and now the IKI being added. We're looking to see how things change over time. These are the early time samples here. These are the later time samples here. Okay, so which one of those do you think you should click? Which one of those observations is accurate? Anybody want to take a guess? Bethany. Yes, they are all dark blue. You're right, Chris. They are all dark blue. All of the time samples, you can see them. They're all dark blue, black in color. All right, that is correct. Now, what do we know about the reaction? Select 3 claims based on what we observed. Do any of these still have starch in them? None of them or 100% of them? We know 100% of them still have starch in them because that IKI is blue in the presence of starch. Has the starch been all digested or none of it's been digested? Well, none of it. It's all still there. This demonstrates what would be observed if enzyme action was high or enzyme action was low. Well, there's no enzyme action at all, so it can't be high. We don't have an enzyme, so it has to be low. We need all 3 claims. So we're going to click submit. All right, those are all correct. Now we go on to make a change. We're going to click change in the interactive and add enzyme to the starch by selecting yes. Change. Yes. Load. Now we're going to watch the video and we're going to describe the observations from the video. We're going to again compare the early time samples to the later time samples. All right, so now there's enzyme in these test tubes along with the starch. Ready? So what's happening to the starch in the test tubes over time because of the saliva?
They're becoming more yellow.
They're becoming more yellow. Yep. So what do we know about the starch that's in there? Well, let's first of all describe the observations. Let's not hypothesize yet about the starch. What we're noticing is that the early time samples are black and the later time samples are yellow. So the early time samples are yellow, the later are black or all are yellow. This is the correct one. They started out black and they are becoming yellow over time. Now, number 5 tells us, recall that the black color indicates the presence of starch, while yellow indicates the absence of starch. Now we're going to identify the earliest time that indicates there's no longer starch in the sample. Remember, starch is black in the presence of IKI. It turns it black. So now at what point we're going to look and see where did the change occur? Where was there no longer starch? So clearly here there's no longer. We keep going backwards until we say, okay, where was there a change? Probably in between the 30 and 40 seconds is where we see the change occur. There's definitely still starch here. A little bit there, probably in the 30 to 40. So let's say 40. Let's put that down. Let's say 30 and see what happens. Let's say 30 because 30 is close. Okay, that's right. somewhere around this mark, there's no more starch, as indicating by the color remaining yellow when the sample is added. Okay, it would give me the same answer for 40, because these two are where we start seeing the change happening. Beyond here, it just maintains the same. Okay, now, number 7, make a claim about your observation with the enzyme added. What do you guys think? Was there, so 2 of them say there was a reaction. 1 says, 2 of them say there wasn't. Was there a reaction? Yeah, there was a reaction. We can see the color difference. We can definitely see that there was a reaction. So we can process of elimination, get rid of the 2 that say there was not. So there was a reaction when starch was added to the solution. There was a reaction and starch was removed from the solution. Which is correct?
Removed.
Yes, the starch was removed. At the beginning, there was starch. We know because the IKI turned it black. At the end, there wasn't because the IKI didn't turn it black. So we submit our answer. That's right. The color changed. The solution had starch. Then over time, the starch was removed. Okay, now that's the end of that one. We're going to look, though, at another enzyme. So pepsin is an enzyme that we have in our stomach that helps to digest protein. So in this interactive, we're going to see an egg white cube right here, and it contains protein because egg whites have protein in them. It's suspended in a solution with the enzyme pepsin. All right, information only. Come down here. Ensure the conditions in the interactive are protein with no enzyme added. Protein, no enzyme added. All right, now let's watch and see what happens when there's no enzyme. Think about what you think is going to happen. Make a hypothesis. When there's no enzyme, nothing's going to happen. It didn't change. So what happened to the egg over the course of the video? It stayed the same. The egg stays the same size. All right, now we're going to change things. We're going to add an enzyme. So we are going to click change and say yes to enzyme and load. Now let's watch and see what happens when the enzyme is added to the solution. This is, of course, very fast speed. See the timer counting down over there, 21 hours. So over 24 hours time, what happens to the egg? It's decreasing in size. It's getting smaller. You can see that happening there. So make a claim about the enzyme. It does not make a reaction in protein, or it does make a reaction in protein. It does. We saw the reaction happening. All right, now let's look at another one. This is how we're doing with time. Good. So we have another one. This is the third enzyme that we're going to look at. In this setup, right here, you see hydrogen peroxide solution in the left test tube. That's right here, the left test tube. And you see a gas collection tube on the right here. So it says, this is our peroxide reaction tube, and this is our collection tube right here. Find the interactive that allows us to explore hydrogen peroxide right here, hydrogen peroxide. We want to make these conditions, no enzyme added, and play. We're going to observe the video. So what we are looking for a reaction in the reaction tube over here. Nothing's happening, no reaction. We can fast forward to the end here and see still nothing's happening all the way at the end. All right, now measure the amount of gas that is collected in the test tube. What do you mean measure it? How do I measure it? Well, we can click on this little hint right here. How do I measure the amount? Click on the tool icon right here. Click on the ruler tool, and there it is. That's our ruler tool. So now we want to measure the amount of gas that was collected. None. It's all water. It's all still this blue liquid that's in there. So we're going to say 0 was collected. There was no gas collected at all. And that's correct. Now let's change things. Let's put enzyme in. We're going to change enzyme added. Yes. Click load. Now we're going to observe the video, and we're going to measure the amount of gas that is collected in this collection tube. Pretty quickly, gas starts being produced when enzyme is with the hydrogen peroxide. We'll watch till the end, and then we're going to measure using that ruler. What do you mean, Luke? Yours doesn't look like this?
So the picture and the video look the same, but on the bottom when it says enzyme added and molecule, mine just has enzyme concentration and percentages.
For question number 14?
No, for like the video, like for the percentages, like for like if it has, you know, how much molecule slash hydrogen peroxide.
So when you click change, you have a percentage here?
No, it doesn't have that at all. It just has enzyme concentration, and then when I click on that, it says percentage. It has percentages.
Anybody else have the same thing? I wonder if it's on the same, or maybe you're down one farther. Yeah, you're down
Yeah,
one
that's
farther.
mine.
Yeah, you scrolled down a little too far. You were doing part 3. We're still on part 2. That's okay. All right, so we are on question 14 in part 2. We added the enzyme. Now we're going to measure. So when we measure, we're going to go at the bottom of this meniscus, at the bottom of this little thing right here. So it's going to be 10 milliliters, 20, 30, but we're not quite at 35. So maybe 33 milliliters. So let's put in 33 and submit our answer. That's right. That's a difference between the last trial when we observed when no enzyme was added. So now what do we know about the enzyme catalase? When the catalase was added, there was not a reaction and no gas was produced. No, that's not true. When the catalase enzyme was added, there was no difference in the amount of gas produced from the trial when no catalase enzyme added. No. When the enzyme was added, there was a reaction that produced gas. We saw the gas being produced. That's the one we would select. All right. All right. So we've now observed 3 different enzymes and their relationship with different molecules. We observed the relationship between amylase and starch, pepsin and protein, and catalase and hydrogen peroxide. These are all enzymes that appear in the human body. So let's describe the pattern that you observed from all of the enzymes. When enzymes were added, no reaction took place. Not true. When enzymes are added, a reaction happened that was not seen when no enzyme was added. Yeah, that's true. Let's see if there's another one though. When enzymes are added, no reaction took place. Not true. When enzymes are added, reactions happened that were the same as the trial where no enzyme was added. That's not true. So we know we have the correct answer right there. Now we want to make a claim about the function of enzymes in organisms. The function of enzymes is to prevent reactions from happening. Enzymes have no function in the body, or the function of enzymes is to make reactions happen. We know that one. It's to make reactions happen. We're going to submit our answer and we're going to go to part 3. You guys might have to lock it again and continue. I'm not sure from the student perspective. All right, so we are, I believe, yeah, we're about out of time. So you guys, if you have time right now, please continue doing this. When you get to the end, submit it. I would like to see what it looks like when students submit. I will not be grading this though. So try to do the answers. If you don't have time now, if you've got another class or you got to go eat or something, that's fine. You don't have to do more, but I think it's a cool experiment. And this one especially is pretty cool. And then you get to the end here, like there's a chart that it'll show, it'll fill in. And then you get to this one, which talks about different pHs and for different sugars. So try to work your way through this if you can. You can also go up to the top, at the very top of the page. I don't have one because this is the teacher account, but there should be one that says save and exit. You can save your work if you can't finish it all right now and then come back in later. You will enter by going to pivotinteractives.com and then you will put in your username and password and it should take you right back to that page where you'll see the activity that we just did. Yeah. All right. So as you're going through this, if you're able to finish it, if you have any questions or there's something that you think I might need to know, please let me know. This is our first year using Pivot Interactives. So I want to make this as meaningful to you guys as I can. All right. Thank you very much. Great to see everybody. I hope you have a great week and I will see you next week. Bye. Thank you for coming.